Hi friends! So today we're going to go back over the two problems we talked about yesterday, which was the bracelet problem and the party problem. So here we had Stacy has 18 bracelets, that was our total. And after she organized them by color, she put them in 3 equal groups. She divided them into 3 equal groups, and we figured out that there were 6 in each group. So here we knew the total was 18 because that's what the problem told us. We knew that she put them in 3 equal groups, and what we were trying to figure out was how many were in each group, and that was the 6. How many were in each group? That's what we were trying to figure out. So we figured out how many were in each group. I'm going to put that right beside the 6 so we don't forget that. And then here we have the party problem. Next weekend my friend Cindy is having a party. 18 people are coming. That's my total. I told her I'd help her set up the tables. We know that 6 people can sit at each table. So we're going to divide these 18 people into 6. And we know that we got 3 groups. So here we knew the total was 18 because it told us 18 people were coming. We knew that 6 people were going to be able to sit at each table. But what we didn't know was how many tables we'd need or how many groups. So for this one we needed to know how many groups. So although the numbers were the same in each of these problems, they were different because we were solving for different things. In this one we were solving for how many were in each group, and for this one we were solving for how many groups. So that's how they were different. We can see that the 6s and the 3s are flipped because we were solving for 2 different things. That's why it's important to label our work and decide what we are solving for. So let's practice one. Cindy plans to buy 15 burgers. 3 burgers come in each pack. How many packs should she buy? We're trying to figure out what the 15 and the 3 represent in this problem. So here it tells us we have 15 burgers and 3 burgers come in a pack. And we're going to think of this word pack as group. So 3 burgers come in each group. So we know that the total is 15, and we know that we're dividing them into groups of 3. So I know that 15 is the total. We're dividing them into groups of 3. 3 is how many burgers are going to be in each group. So what do we need to do to figure out how many packs or groups Cindy needs? I went ahead and put our burgers here. There are 15 of them, and we're going to put them in groups of 3 until they're all used up. So 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. And 1, 2, 3. So I took my 15 total burgers. I divided them into groups of 3. So here are my groups. Here's 1 group of 3, 2 groups of 3, 3 groups of 3, 4 groups of 3, and 5 groups of 3. Now the question asked us how many packs should she buy? And we're going to say groups. How many groups should she buy? Well, we have 1, 2, 3, 4, 5 groups. So we know that she needs 5 groups or 5 packs. So we know that the total, which was 15 burgers, divided into 3 in each group, gives me what we were looking for, the unknown, which was the number of groups. So we had 5 packs or 5 groups. 1, 2, 3, 4, 5. So now that we've done this, we can use what we already know to answer these questions. How many burgers does Cindy have in 1 pack? Well, we know this is 1 pack. Remember, 1 group is 1 pack. So how many are in that group or in that pack? We know that there are 3 burgers in 1 pack. Well, if there's 3 burgers in 1 pack, how many are in 2 packs? 6. 3, 6. We can count by 3s. So 2 packs would give us 6. How many are in 3 packs? 9. Then there would be 12 in 4 packs and 15 in all 5 packs, because we know she had a total of 15. Why did we stop at 15? If we were counting 3, 6, 9, 12, 15, why did we need to stop at 15? Take a second and think. Yes, we needed to stop at 15 because we know that there were 15 total burgers. We can't have more than what the problem told us. So we're going to practice counting by 3s, and every time you count a 3, you're going to hold up a finger. So 3, 6, 9, 12, 15. Guess what this tells me? 3 times 1 is 3. If I count 3 twice, or 3 times 2, that's 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. Or you could say groups. 1 group of 3 is 3. 2 groups of 3 is 6. 3 groups of 3 is 9. 4 groups of 3 is 12. 5 groups of 3 is 15, just like shown here. So let's practice. We want to do 21 divided by 3 equals blank. So what I want you to do is I want you to pause the video and on your whiteboard solve these 2 problems, and we're going to go over them. Alright, so let's go over this. Now, this doesn't have any labels or a word problem, so we don't know if we're solving for the number in each group or the number of groups. So we're going to do one way and one the other. So this one, we're going to pretend like we're solving for the number of groups. So that means that this 3 is how many are in each group. So I'm going to make groups of 3 until I get to 21. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So how many groups do I have? 1, 2, 3, 4, 5, 6, 7. So your answer here should be 7. So let's pretend this time we're solving for how many are in each group. So that means that this 2 represents how many groups. So I'm going to make 1 group and 2 groups. And I'm going to add 1 to each group until I get to 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 2 groups, and in each group are 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So both of these equal 7. This one is 7 groups we were solving for. And this one is 7 in each group. Takes me a long time to write on here sometimes. All right, so now we're going to look at your problem set. We're going to do numbers 2 and 4 because we did 1 and 3 yesterday. Divide 8 lollipops into 2 groups. So I kind of see almost an array here. So I'm going to kind of divide them here like this. Oops. There's 1 group and 2 groups. So I divided them into 2 groups, and let me make sure they're equal groups. 1, 2, 3, 4, 1, 2, 3, 4. Both groups have 4 in them. So we made 2 groups, so there are 2 groups. And the 8 divided into 2 groups gives me 4 in each group. And then for number 4, it says divide the shells to show 12 divided by 3, where the unknown, what we're looking for, represents the number of groups. So if the unknown represents the number of groups, that means this 3 must be the number in each group. So I'm going to make groups of 3. There's 1 group, there's another group, here's another group, and here's another group. So now I have 3 in each of these groups, and I need to figure out how many groups there are. So, how many groups are there? 1, 2, 3, 4. So, 12 divided by 3 equals 4. A total of 12 divided into groups of 3 equals 4. Number 5, Rachel has 9 crackers. She puts 3 crackers in each bag. Circle the crackers to show Rachel's bags. So I know my total is 9, and I know she puts 3 in each bag, so I know how many go in each group. I know 3 go in each group. So I'm going to make groups of 3. 1, 2, 3. So, write a division sentence where the answer represents the number of Rachel's bags. Well, we know that the total goes first in a division sentence. We divided them into groups of 3, and we know that there are 3 groups or 3 bags. And we wanted to make sure that our answer represented the number of bags, and there are 1, 2, 3 groups or 3 bags. So now we're going to draw a number bond. So in a number bond, we know my total goes at the top. And I divided 9 into 3 groups of 3. And this number bond's a little different than the repeated addition number bonds that we did. We're pretending like this is a division problem. 9 divided by 3 equals 3. And you can check your work, and we'll talk about this a little later, but if you know that 3 times 3 equals 9, that's the same thing as 9 divided by 3 equals 3. It's the same thing, but don't worry about that right now. We just need to break apart the total here, the number we divided by, and the answer. All right, great job today, guys.